In this video, we are going to prove this theorem. Let x be a random variable to be defined to have negative binomial distribution. Then, the expectation of x is equals to rq over p, and the variance of x is equals to rq over p squared, where q is equals to 1 minus p. But first, we are going to recall some properties and theorem. Number 1. P of x given x is equals to the combination of r plus x minus 1 taken x times p raised to r times q raised to x is the PMF for negative binomial distribution. Number 2, the summation of P of x given x is equals to 1. Number 3, the formula for expectation of x is equals to the summation of x times f of x, or this is the PMF of x equals to 0 to infinity, for the variance of x is equals to the e of x squared minus the expectation of x squared. Now we're going to start the proof. Now we're going to start with the expectation. We know that the expectation of x is equals to the summation of x times the PMF, where the PMF is equals to r plus x minus 1 taken x times p raised to r q raised to x. Now we're going to manipulate this summation. Take a look of when x is equal to 0. This whole thing is equal to 0, so we're gonna start at 1. But we know that this part is equals to r times the combination of r plus x minus 1 taken x minus 1 times p raised to r q raised to x. Then let's make the constant outside of the summation. So r, and we're gonna take 1 of q and minus 1 of p. So times the summation of combination of r plus x minus 1 times p raised to r, we're gonna add 1 here, times q raised to x minus 1 here. As you can see, and let k be equals to x minus 1. So it is equals to the expectation of x r q over p summation of the combination of r plus 1 plus k minus 1 of taken k p raised to r plus 1 q raised to k. And as you can see, this summation is equals to 1. So our expectation is equals to r q over p, and we're done with the expectation. we know that the variance of x is equals to expectation of x squared minus expectation of x squared. Then if we add 0, it is equals to expectation of x squared minus expectation of x plus expectation of x minus expectation of x squared. And it is equals to expectation of x squared minus x plus expectation of x minus expectation of x squared. And this is equals to expectation of x times x minus 1 plus expectation of x minus expectation of x squared. Now we're going to get this one. Now, the expectation of x times x minus 1 is equal to the summation 0 to infinity of x times x minus 1 times r plus x minus 1 factorial over r minus 1 factorial x factorial times p raised to r times q raised to x. So we're going to manipulate this, but we can start at x equals 2 into infinity. Then we know that this is equals to r times r plus 1 q squared over p squared times r plus 2 plus x minus 2 minus 1. We add 0 here over r plus 1 factorial because of this times x minus 2 factorial times p raised to r plus 2 since of this times q raised to x minus 2. And then it is equals to r times r plus 1 times q squared over p squared of this times the summation of r plus 2 plus x minus 2 minus 1 over r plus 1 factorial x minus 2 factorial times p raised to r plus 2 times q raised to x minus 2. But this summation is equals to 1. So the expectation of x times x minus 1 is equals to r times r plus 1 q squared over p squared. Thus, variance of x is equals to expectation of x squared minus x plus expectation of x minus expectation of x squared but this is equals to r times r plus 1 q squared over p squared plus r times q over p minus r squared times q squared over p squared. But this is equals to r squared times q squared plus r q squared plus rpq minus r squared q squared all over p squared. Cancel, cancel, and this is equals to r times q times q plus p over p squared, and this is equals to rq over p squared, and we're done.